Hey, what's up? I'm Jason. It's great to be here. I'm super passionate about voice over IP security. This is Arjun. I'm going to start off with a quick little story, and it's the reason why I like Las Vegas so much. We were here last month. Viper spoke at SANS Pen Test Summit on voice over IP pen testing, and only in Las Vegas do I get taken up onto the stage of Cirque du Soleil's Humanity. And little did I know that they were going to try and take off my pants. The girls. That's not a bad thing when girls want to take off your pants, but lucky for me, I wasn't wearing any underwear. So I kind of escaped that part. Lucky for the audience as well. So I was telling the SANS guy this story, and it was kind of funny because they nicknamed me Commando, and it was Paul Asadorian with Paul.com Security. I hope he's in the room, but anyways, Paul, so he called me Commando. So I think that's going to be my new handle now, Commando. And yeah, so Paul, wherever you are, I want you to know that I'm going Commando for this talk, in your honor. So let's get started here. We got a lot of stuff to talk about. I'm going to go really fast at the beginning on the overview of UC, and then we got 3 really cool demos to do. We're going to talk about like an intro to like some of this video stuff that we're talking about. And if you guys stick around to the end, the last 10 minutes, we're going to have some awesome, like really cool pen testing stuff, lessons learned and tricks that we learned here a few weeks ago. So Viper stands for Voice over IP Exploit Research, and really all we are is we're a highly specialized pen test firm dedicated towards UC and voice over IP. We do structural research on generic implementation of VoIP and finding vulnerabilities in VoIP protocols, but it's basically penetration testing, and then our research around this. We built a real production enterprise network. It's basically Cisco, Avaya, and Microsoft. And what we do is we go in and we do the pen test with the customer. We learn more about the configuration. We recreate it in our lab, and then we're even more effective in our pen tests, and our research feeds into that. So obviously this is Arjun here. I'm Jason. We're Viper team members. This is our lab actually in Dallas, and like I said, we have a Cisco network IPS. We can do all types of VoIP exploits through the network IPS. We have like Cisco, Avaya, and Microsoft phones, and video phones, and so forth. So UC definitions. At first, it was the first marketing buzzwords was a convergence, which was voice and data over the same pipe. I added that. My definition of unified communication is just adding video into that, and we also have presence as well. So this is just a simple slide. Just like, why do we do what we're doing here? We're publishing these free assessment tools for education and awareness because we believe that the only way to show people that VoIP attacks are for real is to actually demonstrate it to them. And the way you do that is you use security tools. We enable security professionals to test the network, to show the customer the risk of VoIP. And we also enable like VoIP owners, like people deploying VoIP, to test the network themselves so they can see the risks, because they're really the ones that have to make the risk decision if their risk tolerance level will accept that risk. So let's look at some real-world business examples, and we're talking about IP video here. So private IP video calling between users, like the CEO calling the CFO. Telepresence, or video conferencing. IP video surveillance, which we're going to take a close look at. Then there's these video streaming applications, and it's really interesting to study these. And we welcome you guys to come to us if you've seen stuff, because all this stuff is new in the market, and we're just now seeing this come out. Okay, so here's a business case. We're just taking a quick look at what is driving these video rollouts. So saving money, going green, not having to save on travel costs. Wachovia, as a result of their telepresence solution, cost cuts. And then IP video surveillance. We're kind of taking a look at these video analytics applications that you can do programmable user-driven analysis automated on DSPs and co-processors that are on the video surveillance cameras. Okay, on the IP video streaming applications, we have America's team, the Dallas Cowboys. Brand new stadium, awesome. And we've got a lot of stuff in the press about the Dallas Cowboys. They have an all-IP video network. It's this new Cisco Stadium Vision technology. Cisco's partnered up with the Dallas Cowboys, and supposedly every single TV, IPTV, the video boards and everything all has an IP address. So what does that mean for us? A lot of fun. Now the Cisco Stadium Vision is like targeted revenue streams where they can like customize the whole view of all the IP phones and all the IP TVs. They can customize that for whatever the event is. If it's like a Cowboys game or if it's like a concert and so forth. The two 60-yard long HDTV video boards are the largest in the world. $40 million. They're manufactured by Mitsubishi. Yankee Stadium is also doing this as well. Toronto Blue Jays. Okay, here, let's take a look at some example UC attacks. Now we're looking at is the video replay attack, where we can replay. Thank you, Coop. Appreciate that. What's your blog website again? Heycoop.com. Check it out. Good guy. Video replay. We can do a video replay against an IP video surveillance system by placing a safe video stream and creating the blind camera. And then while the bad guys are sneaking in and doing the bad stuff. We can also, we've actually seen some people do this. We can record the CEO in the middle of like a conversation. We had one guy use UC Sniff to do this, and he showed his CEO that he had recorded the live conversation. But you can actually replay that. So imagine if, like, in the middle of an important conference call, there's like a previous conference call from 2 weeks ago, and the CEO is like saying the same thing. A little strange. Okay, IP video hijack. We're calling this video interception, video denial of service. So we're intercepting the video, and then we're playing whatever we want, whether it be replaying a previous like AVI or taking a random AVI clip and playing it against the target video session. And then we have the video eavesdropping example that we just talked about. Okay. I want to do like an overview of UC Sniff. Now, UC Sniff is our next generation VoIP sniffer. And I want to walk through like what the progression of UC Sniff and what's happened with UC Sniff. First of all, there's no other security software that can decode G722 audio codec automatically. If people try and use Wireshark and EtherCap when they're doing their VoIP sniffing in a pen test, you're limited because you can't actually reconstruct G722. This is the first security tool that does G722, which is the new codec that's showing up in all the new Avaya and Cisco networks. Also, UC Sniff, the very first, we released this right after TourCon, combines a man-in-the-middle ARP poisoning, automatic VLAN hop, and auto-constructs forward and reverse into a single WAV file for both G711 and G722, all of this done automatically. Another thing is we have a target mode that we introduced, and we've done this in a pen test. We can actually intercept Cisco Unity voicemail passwords. We can steal voicemail passwords. And we do that by intercepting the skinny keypad button messages. So the design of UC Sniff is a little different because we basically combine the signaling and the media together. We don't actually start eavesdropping on the RTB media until we've detected that a call has started via the signaling. So we use SCCP or a SIP to detect that started. Then we close down the RTP dissector after we know that the call has ended. The result of this design is we can tell who is calling, not just random IP streams. We can actually, if you see the screenshot here, we can reconstruct like who's tied into the corporate directory. Like the CEO is calling someone else. And in security testing, the reason why we did this is time is money with pen testing, and I don't want to spend like a lot of time like trying to search through WAV files and so forth, trying to find what I'm looking for. So another new feature of UC Sniff, the very first feature with 1.0, was we actually mimic the entire behavior of the phone, and this is the phone on the left, to download the corporate directory, and we load it into memory of the tool. So we're actually targeting corporate VoIP users based on their name or their directory entry in the corporate directory. Now, UC Sniff 2.0, when we released this February, is the first ever IP video sniffer. So there's no other tool out there doing that right now. we decode the H.264 video codec, which Arjun's going to go into in detail. So we didn't stop there. We're going to keep on going on this. April 2009, we released another version that could eavesdrop on Microsoft OCS IM conversations because they use the SIP subscribe message. We have support now for Avaya SIP as well. We stress tested that in our lab. We've actually enhanced the ARP poisoning with unicast ARP requests. We're going to talk about that in a second. And now we have support for G711 A-log codec. So the gratuitous ARP thing is really, really, really cool stuff. We were researching and we found that like these nice 7985 video IP phones, that we couldn't actually ARP poison them unless we sat there with UCSIF for 10 minutes. So we designed like unicast ARP requests, which actually speeds it up. Now we can do ARP poisoning like immediately. We just hit a button and they're ARP poison. We found the same thing with Avaya IP phones. They actually don't advertise a feature, but you cannot ARP poison Avaya phones at all unless you use unicast ARP request. But also, we ran into a problem because the unified IP phones have a GARP disabled feature, which we're going to talk about here at the end, and that really kind of stymied us on a lot of things. So UCSIF 3.0, I'm going to get into this in a second. We have a GUI now. We have a Windows port. We have Windows VLAN support, thanks to Arjun. We're working on a real-time video monitor where you can actually like eavesdrop live and see like both ends of the reverse and forward video. We actually built Cisco UCM 7.0 and 7.1 support. That was not even like, it didn't work at all in the old versions of UCSIF, so we're going to release this in a second. All the new deployments are 7.0, 7.1. And then we have GARP disablement bypass. I'm going to run out of time here. GARP disabled is the feature that I was telling you about. And I still have 5 minutes? Okay, so GARP disabled is basically preventing us from ARP poisoning the connection from the phone to the network. We can still do the network to the phone, but when this feature, and this is the default now in new deployments, so you're basically, unless the phones are on the same VLAN, we're going to get to a second how we defeated that. But basically, no successful ARP poisoning means no man-in-the-middle condition. And we can only get the downstream connection coming from a remote VLAN into the phone, but we can't get we can't reconstruct the entire media, especially for the phone going to the network in a default config. So basically, we devised like a new feature, and what we did is we're going to beat the race condition on the phone, because we can actually predict when GARP is disabled, what happens is the phone will send an ARP request as soon as the two RTP peers, right? So as soon as the phone, let's say that both phones are on the same VLAN, they're going to send an ARP request right before the RTP media starts. So we actually program UCSIF to look for a message called start media transmission, which is basically the server telling the phone who the remote RTP peer is, right? So when that happens, then we know we can actually construct our own spoofed unicast ARP reply packet, and we can actually flood both phones. And so that's how we're winning the race condition. We actually ARP poison the phones that way. So this is the entire process here, and it's the new feature. It's -- GARP disablement bypass, and that's going to be released with UCSIF 3.0. So, but with this though, if both phones are on the same VLAN, we can definitely reconstruct the media because we can use this feature to beat them. But the phones, when they only send the ARP requests when they boot up and talk to the server. So like when they're talking to remote peers, we can't defeat that right now. But that's another story. We actually can, but we're going to get into that later. So, like I just said, we can only get unidirectional if it's remote peers in another VLAN. Okay, ready, Arjun?
Hello, guys. I'm going to talk about the UCSNF development and show you a demonstration of IP video eavesdropping using UCSNF. So UCSNF GUI, we developed it using the Juice libraries. So Juice is a C++ class library for developing cross-platform applications. So it's really good for creating highly specialized user interfaces and for handling graphics and sound. So it's really easy to create a GUI application using the Juicer, because like the Juice libraries come with an application called Juicer, and it also has like some sample demo applications. So why we selected Juice libraries for developing the GUI? We needed a cross-platform C or C++ application so that UCSNF GUI looks the same way in Mac, Linux, and Windows. So we are currently working on porting UCSNF to Mac. So UCSNF Windows port. So we ported the UCSNF Linux code to Windows using the MinGW. So MinGW stands for Minimalist GNU for Windows. So basically, it ports all the GNU GCC and the GNU binutils for development of native Windows applications. So creating a voice VLAN interface on Windows. So actually creating a voice VLAN interface on Linux is pretty easy and straightforward. But on Windows, we have to follow the toughest procedures by developing two network drivers. So we have to develop an NDIS protocol driver and an intermediate driver using the Windows driver development kit. So we will be releasing these two drivers as a separate package along with UCSNF. So what is NDIS? So NDIS is a Windows network driver interface specification. So we use the NDIS protocol driver for querying and setting the .1 queue tag on the Ethernet interface. So we can also use the NDIS protocol driver for sending and receiving raw Ethernet packets on Windows. It can be used like libnet, but it's like more programming than using libnet. So installing NDIS prod. So we used an open source tool for installing NDIS prod. So it's called prod install. You can see a screenshot of NDIS prod getting installed. So starting the NDIS prod service. So you just need to execute net start NDIS prod. So the NDIS prod is installed as a service. So just start it from the Windows command prompt. So we will be all the steps will be automated before we officially release UCSNF. So the IM driver. So what does the IM driver do actually? So it creates the actual virtual interface for both the wired and the wireless connection. So this virtual interface will be tagged with the voice VLAN ID, and the interface will be a part of the voice VLAN. Next slide. So installing IM driver. So we added the support for installing and uninstalling the IM driver on the open source NDIS Pro tool. So here's the interesting thing, decoding video support on UCSNF. So UCSNF decodes the H.264 content from the RTP payload format. So this decoder is compliant with the RFC 3984, which is the specification for the RTP payload format for H.264 video codec. So then UCSNF creates a raw H.264 file format using the decoded H.264 contents. So, but this video file is only playable using VLC and MPlayer, and it does not have any audio. It's only a video-only file. So, if you have configured UCSNF with the FFmpeg library support, UCSNF adds an AVI container to the video files that it creates, and it also muxes audio and video together using the FFmpeg libraries. So this AVI file can be played using any famous or well-known media players, including Windows Media Player. Here's a screenshot of the new UCSNF GUI, just an overview. Here's a very cool animation. So here's a cool animation that shows how UCSNF works. It's pretty simple and very basic. So all you need to do is unplug the phone from the Ethernet wall, plug in UCSNF. UCSNF uses CDP. It's a Cisco Discovery Protocol for finding the VLAN ID and for creating a VLAN interface. Then it uses DHCP to get an IP address in the voice VLAN. Then it ARP scans and ARP poisons the voice VLAN. So at this point, UCSNF is a middleman. It receives all the traffic from the network and forwards it to the right destination clandestinely. So for any active call that comes through, UCSNF stores the media to a media file, and then it forwards it to the right destination. This is how pretty much UCSNF works. So now I'm going to show you a demonstration of IP video eavesdropping using UCSNF. The targets are the two Cisco 7985 phones. Let me start UCSNF. This is UCSNF. So I'm selecting the interface to VLAN hop and to sniff the wipe traffic. Which interface to use?
Remember NetStart and NDIS Pro. Remember you forgot NetStart.
I have to start the NDIS Pro service. I forgot to do that.
We're going to need a volunteer here in a second.
I'm selecting the man in the middle mode. So there is an option to VLAN hop. So there are like three ways to VLAN hop: by spoofing CDP, or by sniffing CDP, or by specifying the VLAN ID. So spoofing CDP is the fastest way to learn the VLAN ID and to VLAN hop. So I want to download the corporate directory. So in a Cisco network, MAC address of the phone is an authentication token for downloading the corporate directory. So you can get the MAC address of the phone from a small label on the back of the phone, or from the network configuration settings if the screen is unlocked. So I have memorized the MAC address. So there are two man-in-the-middle modes. Number one is the learning mode, and the second is the target mode. So in learning mode, UCSNIF or poison all the hosts in the network, and then it eavesdrops on every phone call. But in target mode, we can target like specific users, and then eavesdrop only on phone calls to and from that user. We recommend using the target mode because the network impact is really low during penetration testing or security assessment. So Jason is going to talk more on this after the demo. So I'm enabling unicast or request poisoning. I'm starting UCSNIF. So it has discovered the VoIP VLAN, which is 200, and it's waiting for an IP address. There you go. It has downloaded the TFTP configuration file for the MAC address specified. It has also downloaded the corporate directory. So here's the directory list. It's the same as you can browse through the phone. Here's the host list. It's the active calls tab. There are no current active calls. Here's the media files tab, which shows the current media files in the current working directory. So UCSNIF has a built-in audio player. We are also working on a video player as a plugin. Here's the targets list. So we need a volunteer to make a video call with Jason.
Anyone?
Yeah.
You, sir? So we got a nice video conference set up. Ready?
Yeah, ready.
I'm going to call you. Pick up. Hello?
Hi, howdy.
What's up, man? Can I get the password? No? Alright. Woo! Alright, see you later.
So there you go. UCSNIF has created like three media files. So number one is the bidirectional audio stream. Let me play that.
Hello? Hi, howdy. What's up? Can I get the password? No?
Does it play? It's not playing. It's playing, but it's not.
It's alright. It's alright, dude.
It's all right.
Let's go to the video.
Hello?
Let me play the video files. Here's the forward direction video file from the calling phone to the call party. There you go.
Hello?
Thanks, man.
Thanks, man. You know, we're going to put it up on YouTube later on tonight, so you can see your stuff up there.
Here's the reverse direction video file. I think your audio driver is messed up. It's not working.
So there you have it. First video eavesdropping, GUI written. We do the phones too. Give us 1 second. We're just getting back set up here so we can jump on to the next one. So what we have here is we're going to be talking about Video Jack next. And Video Jack is our IP video interception and replay tool. It's like hijacking IP video. And it's basically like a cousin tool of UC Sniff. It has man-in-the-middle feature supports. And what we're using is one of our, we're going to be targeting unidirectional video streams. Looks like it has a problem, so you're going to have to. Okay. Okay, so Video Jack was released February 2009 along with the UCSIF video support. It's a free assessment tool hosted on SourceForge, and you can go download it right now. But we're about to release this new version of Video Jack here right after DEF CON. But it is this first security assessment tool to support H.264. Even before UCSIF, we were using Video Jack all the time. We first started targeting the two 7985 Cisco Unified video phones. And now we just moved into the realm of video surveillance security. So we're going to be talking about this 1080p high-definition video surveillance camera, Cisco 4300 series camera. Okay. Did you reboot the surveillance camera? Let's go ahead and do that. Let's give it a second. Okay. So the new features of Video Jack is it can replay an AVI file in a continuous loop. It can do a targeted video DOS against a random AVI file that we select, which is essentially the same attack. But we can actually also take a raw H.264 file and replay it against the phones. So we're working on getting that going against the surveillance camera. Can you talk about this while I work on this? Here.
So I'm just going to talk about some trivial challenges we faced while developing Video Jack. So number one is finding a valid H.264 RTP stream. It is very easy to find a H.264 RTP stream if we can intercept the signaling and the session being negotiated. But what happens is initially the session and the signaling gets negotiated at the very beginning, and it does not happen very frequently once the session is established. So particularly in the case of IP video surveillance camera, so we cannot. You got it? Okay. No. So particularly in case of IP video surveillance camera, the media could be streamed to the destination for days without having any signaling taking place. So we thought how to find a valid media RTP stream without any signaling. So we came up with a module that intelligently detects a media stream just by looking at the IP and the UDP parameters and the RTP version and the RTP payload type and the SSRC and also the monotonically increasing sequence number and timestamp values. So we do this for a periodic interval of 15 to 20 packets, and if the RTP packet matches any of one of the RTP stream, we try to map it to a valid RTP stream. So here is a screenshot of. Here's a screenshot of a sample capture of a session getting established between an IP video camera and a monitoring endpoint. So here you can see RTSP and the STP, which exchanges the session and the codec parameters. And here is also the H.264 RTP media codec. So H.264 payload format and fragmentation. There are 4 types of H.264 RTP payload formats. Number one is the single network abstraction layer unit. Number two is the fragmentation unit. Number three is the single-time aggregate packets and multi-time aggregate packets. So what a H.264 client does is, if the H.264 payload size exceeds the MTU, the payload will be fragmented at the H.264 level. So these H.264 formats are called FUA or FUB. But some H.264 clients, like the Cisco video phones, they do not handle this FUA or FUB packets. They just drop it. So for a video jack attack to work successfully against this 7985 phones, so we automatically convert the FU type payload to a single NALU type payload. So and then we also fragment it at the IP level so that it works perfectly. So this feature of video jack makes sure like video jack works against like every H.264 video client. So video jack also uses the FFmpeg libraries to convert the AVI and a raw H.264 file format to a RTP media stream. So the converted RTP media stream will be initialized with the original RTP streams, SSRC, payload type, increased sequence and timestamp values, and spoofed source IP, and UDP port of the valid source sender. So, you're going to talk on this?
Oh, yeah. So just an overview of video jack. It's 100.4. I just pinged it. You should be able to connect to it. So we're reconnecting to the surveillance camera, and this is actually a Cisco web ActiveX Control web application, and it basically streams over RTP. So this is not like HTTP that we're doing here. We're actually streaming over RTP, negotiated via RTSP. Looks like we're going to come up here. It's okay. So let's just talk a quick overview of video jack. We're selecting right now a one-way audio video stream that we're targeting. We start the attack, and as soon as we start, we're blackholing the valid RTP packets from the valid IP phone. Then we select the AVI or the H.264 file, and then we're using libnet to reconstruct the H.264 RTP packet. We use like the SSRC, the timestamp values, and other values of the drop packet. So we're basically, it's a very intelligent attack. We're taking everything of the valid drop packet and we're recreating it, but we're putting our own custom H.264 payload in there. The video interception, like I said, can be a replay or a random movie clip. And then we target the video device and send it at the destination RTP port. So here's a little animation to kind of show this. First off, on the network, we have the streams, the valid H.264 stream. The video jack attacker has to have physical access to the port. Now, this could be at a physically remote location, and there's a misconfiguration where the VLAN's a member of the same VLAN where the video network is. So once he basically does the ARP poisoning attack, he creates the man-in-the-middle condition. Now the packets are going through the attacker, but the attacker is just silently forwarding this on. He's not doing anything at this point. Then when he hits the button to start the attack with whichever file he chooses, then what happens is he's actually dropping that packet, he's constructing his own packet, and thus the attack works that way. Okay, here's our target right up here. It's kind of hard to see right here, but it's a beautiful little new 4300 series IP surveillance camera. It's a 1080p high definition. We bought it from a Cisco video surveillance reseller. It uses RTP for port negotiation. It does support security features, like it supports encryption, SRTP. By default, it's not enabled. And it supports 802.1x as well. So like I said, we're using the web application to stream it over. So here's for our demo here. Now, to get us in the mood for this, I have to play this for a second.
Julia. Doctor, you might want to call the rice paddy now.
See that there's nobody in it or out.
Quickly. Okay, sit it down. J-Mo, can you hear me, J-Mo? Talk.
Okay, so they basically took the Fabergé egg, and it was the type of attack that we're going to demonstrate here. Here's our Fabergé egg, the little water bottle over here. Okay, let's give this demo a try. Works. All right. Let's start video jack. So first thing we're going to do is we're going to capture the safe video stream. So we use UC-Sniff to capture the safe video stream. We're running Wireshark. So we're also going to run Wireshark, and we're going to capture into a PCAP the traffic with Wireshark. We have to sample the traffic for about 20 seconds. So we're gonna need another volunteer. So we're on this other laptop, on the attacker laptop, we're capturing this. So this is like a real surveillance camera here. It's watching the Fabergé egg right over there. You get it? Okay, let's stop it. Okay, so UC-Sniff has finished its work. Let's hope that we captured a good video stream. Blah.pcap. It's fine. Okay, what is it? Okay, Arjun saved off. We're VideoJack teammates here. We saved off blah.pcap. So right now I'm going to use a tool called Video Snarf, which is a new tool that we're introducing that basically takes as input an offline PCAP, and it basically detects all the video and audio streams and outputs them into separate files. So if you're like a network administrator and you have a monitor span session and you want to actually see all the video and audio going, you can use Video Snarf, and we're going to release this in a little bit too. Also, you can use like EtherCap and Wireshark. If you don't want to use UC-Sniff, you can use Video Snarf, EtherCap, and Wireshark. Okay, so we detected a couple streams here. Now we're using FFmpeg to convert the H.264 RAW file into an AVI file. So can I get like a volunteer? Let's try and get a girl this time. Any girls? Anyone? Oh, we do have a girl. She's coming up. All right. Round of applause. Okay, you're going to be like the person stealing the egg. Say, don't do anything until we tell you exactly what to do. So go right over here. So FFmpeg is doing its work. And we're ready to start the VideoJack attack. Okay, so why don't you like put your hand like here and just like show that, put it in the water. See, now you can see her hand. You can see that like a video surveillance camera would like capture that. So move your hand out. Okay, now move out a little bit. There you go. Okay. So VideoJack has detected the stream. We select other. We're going to do a looping attack, and we're going to select replay.avi. Now watch the screen here. I don't know if you guys noticed anything. Maybe for a split second there was a problem with the AVI file. But now go ahead and reach in and take the water bottle. Nothing. Let's stop the attack. Whoa. Water bottle's gone. Let's try it one more time. So put the water bottle back. Okay. Replay.avi. Says the water bottle was almost pushed in the same direction. Now remove the water bottle and keep it out. Now watch. Stop the attack. Water bottle gone. Okay. There's VideoJack. Thank you. Actually, you can have the water bottle as a present. Okay, go ahead, Arjun. Take it away.
So here's the last demo. I'm going to show a VideoJack attack by playing a movie clip on an active video conversation against the Cisco 7985 video phones. I'm going to use VideoJack. This time I'm going to VLAN hop. I'm enabling unicast ARP request poisoning. So yeah, it's ready to go. Let me make a video call.
Okay. We're actually streaming like the output. Tell me which target we're at.
Yeah. So I press F to find an active video stream. So I find one from the extension 8000 to the extension 8001. I select the video stream. Now I can do a very precision attack by attacking either one of the two phones. I'm going to attack the phone with the extension 8000. It's the phone on the left. So it's a 7985 model. I'm just going to do a one-time attack. I'm playing the movie clip, Italian Job. There you go. I'm stopping it, so I'm going to target the next extension. So it's 8001, the same procedure. There you go. So I could have played like a pre-recorded video conversation, a pre-recorded H.264 video file, or any dirty movie, or an active video conversation.
It's funny when you say dirty movie.
Thanks, man. So imagine the impact of this at basically you have to monetize this attack, and I don't believe attackers attack for no good reason other than graffiti, but you could do this at like an entertainment venue, like very high-profile event. Okay, so let's jump on to the end here at the exciting VoIP pen testing lessons learned. Okay, so I've been using UCSIF this way, doing on-site pen testing for a while, and it's something I've been meaning to tell a lot of people. I never run UCSIF in learning mode. I always run it in target mode. And one of the problems you run into is like when you're doing the pen test, you want to target like a remote IP phone, but you really don't know the IP address of the phone. So what you can do is you can take a hub into the environment where you're doing your pen testing, and you can share the hub with the attacker's laptop, and you can pick up and find any user in the corporate directory, and you basically call that user, and then you use Wireshark attached to the hub, and you find the IP address of the remote phone, right? It's not something you really think of, but it's very effective, because normally when you're plugged into the Ethernet switch port, there's really not a way you can find the remote IP phone unless you kind of finagle yourself like this way. So I find the IP address, and I create this file targets.txt on the phone within UCSIF working directory. And then I specify UCSIF in targeted user mode. And what it does is we select from a menu, we select the user. UCSIF takes care of the front end for you. And now it's extremely low risk of service impact, because all we're doing is targeting the traffic between that phone and the rest of the network. So if something crashes, it's not going to impact rest of all the IP phones on the network. So it's a very silent, effective attack, and this is the way I recommend it. So it's kind of like a little tips and tricks that we learn running UCSNIF. Okay, now this is really, really cool. This is like I'm saving the best for the last. How much time do we have? Okay, so we were engaged, and there was a Viper security consultant that was in Europe just a couple weeks ago. And basically it was a UCM 7.1 brand new deployment. They had gratuitous ARP disabled. Now, I've actually talked to Cisco PCERT about this. I've already communicated this. This is not something that can't be protected against, so it's something that can be remediated by just turning on security features. But we couldn't intercept skinny keypad messages, and they had the GARP disabled feature on. So the GARP disabled looks exactly like this. Perfect. GARP disabled was no. And I talked about this before, what this means. This means I can't get any messages from the phone to the network. So I can't get the media from the phone to the network, and I can't get anything that the user dials. And it's really nice to be able to steal voicemail passwords. So what did we know? We had to figure out a way to defeat this. We knew that GARP enabled is a setting that's managed server side. We also knew that the Cisco Unified Phone downloads the configuration file via TFTP, which tells the IP phone how to configure itself. So basically, this configuration file was everything that the phone used, that it parses and it learns how to configure itself. And it's only downloaded when the phone boots up. Could there be a way for us to force this IP phone to download this configuration file? This is what we figured out. we figured out a method to do this with UC-Stiff. We call it the TFTP man-in-the-middle modification attack. What we do is we immediately we target the phone. We create targets.txt. We launch UC-Stiff with a new feature that we created for UC-Stiff, which we're about to release. First off, what we do is we drop keep alive ACK messages. Now, this is a heartbeat mechanism between the phone to the server, but we can't intercept what's from the phone to the network, but we can intercept the return traffic back to the phone. So we start blocking the keep alive ACK message, right, from the server to the phone, no matter where the server is. Now, all of a sudden, what the phone will do is it'll think that it's lost registration, so it'll try and re-register to the server. When it does this, it actually does a TFTP get for its configuration file. Well, guess what? When it does a TFTP get, the return traffic, we can add a TFTP dissector. Okay, so we capture the UDP stream on the way back, and all we do is look for and intercept that gratuitous ARP setting. So we take it from whatever its setting is 1, and we change that to 0 to GARP enable. So then UC-Stiff does its work. And Cisco, the phone downloads, finished parsing the file, and now it has the new configuration. GARP enabled, yes. So this all happens in less than 30 seconds. If users watching the phone, they might be able to catch it, but they might not think anything of it. And all you have to do is wait until the users go home for the day, and you target each phone, pick it off one by one, and you, when they arrive for work the next morning, they have gratuitous ARP enabled on all the phones in the environment. We can add new features onto this when we come up with new ideas. So we basically pwn the phone. We can change anything on the phone we want to. I'm going to show and like I said, you can totally remediate this following Cisco security best practices. Now I'm going to show one little quick video of this actual attack. Oh, it just started actually. There we go. Okay, so I'm going to the phone right now, and I'm finding its IP address, 200.6, and then I'm going to its device configuration, and gratuitous ARP is no. We're just verifying that on the phone. And then we go to UC-Stiff, and we launch with the new feature. We select the targeted phone, UC-Stiff ARP scans, it's VLAN hopped. Now it's listening for traffic. It's listening for that for that keep alive ACK message. It's the most important part of the con. So it takes a second here. It's cool, man. See, dropping the keep alive ACK, all of a sudden the phone loses registration on the left. Now the phone is actually like going out via TFTP and getting the new configuration file. We're going to intercept the return traffic from the server, the SERD file coming from the server to the IP phone. In a couple seconds here, it's going to watch the phone. It's going to turn, and we just, on the right, just modified the setting. Now we go into the phone. It's re-registered. And new configuration, gratuitous ARP enable. I guess that's really it. Great time being here. Thanks for everything. And we'll be in the Q&A room. It's room 104. We'll be there for about 20 minutes.